All right, ladies and gentlemen, good morning to you guys on this Monday. Remember, we have about 2 more weeks left, just so people know. Now, sometimes people they've been asleep all this time, and then they wake up at the end. It's kind of like if you ever watch a movie, you go to the movies and maybe you fell asleep, or maybe you're at home and you fall asleep and wake up at the end, the ending is happening, and then people want to know what's going on. You guys know what I mean? That's kind of what's happening right now. So some people have been asleep, now they're waking up at the end of the movie. You guys know what I mean? So good morning to all you guys there. So anyway, let's take a look at see what we're doing. You guys are not in 241 yet. You're in 227. I'm going to go over to our notes. What have we been working on? Do you guys know? Yeah, hypothesis testing. Is that true? All right. So what I'm going to do now here is this. I'm going to go to my, here we go. I'm going to go to my notes here for you guys, and I'm going to do some more hypothesis testing. Okay, and I'm going to put that in the comment section for you guys, in case you guys ever go back and take a look. And there's in my notes. We're going to do some hypothesis testing about a what? About a mean, ladies and gentlemen. Okay, now it's going to be the same procedure. So the procedure is the same. So that's the good news, okay? You guys okay with that? So, oh my God, that's good news. But you have a different parameter. What's the parameter now? That's what? Mu. Is that true? Mu for what? Mean. Now, you say mu for mean for a what? A large sample. What's a large sample, ladies and gentlemen? Sample size is bigger than what? 30. Okay, so what you're now going to do is you're going to test a hypothesis about a mean. It has the same exact format. So you say, oh, is that the same? Yeah, it has the same format. The only thing that's going to be different is in the TI, you have a different what? Command. That's all. And then the sample looks different, but anyway. So let's read this statement now, okay? Because we got to do some reading. This is the thing about hypothesis testing. It's about reading some hypotheses, right? So let's read this. Okay? What does it say? Earthquakes occur at a what? A mean depth of 5 kilometers, okay? As what? As claimed by the Geology Club. Okay? So what parameter are they talking about when they say mean? Mu. Is that true? All right. So what do they mean by a mean depth of 5? That means mu what? Equals 5. And then that is the what? Claim. Are you guys okay with that? So this is going to be your claim. That's what you're starting off with, okay? So where does this go? Remember, we're going to go through the process. We've been doing this process over and over again. It's the scientific method. Where does that mu go? Where is it going to be? Is that a null hypothesis? Okay, what's the logical opposite of that? What's that going to be now? Mu does not equal what? 5. Is that true? Okay, so far so good. Everybody okay with that? Isn't this what we've been doing? Okay, now let's see if you guys are awake here. We draw the decision rule. Is that true? But who can tell me, based on what we were doing last week, what kind of test is this? Is this a one-tailed test? Is it a two-tailed test? What kind of test is this? How do you know it's a two-tailed test? Right? The alternate hypothesis tells you if it's not equal, what do you guys know? Two-tailed test. Is that right? Okay, the alternate hypothesis tells you. So now we have a two-tailed test. Are we okay with that? Easy peasy? So you say, Mr. Judge, this stuff is easy. You've been doing how many of them? You don't want to do it the night before. So what goes in the middle? Right? What goes in the middle? Do not reject the what? The null. And then what goes over here? You're going to reject the null. And over here, you're going to what? Reject the null. Is that true? So far, so good? Isn't this exactly what we've been doing? Okay, now we need we're not done with the decision rule. Why aren't we done? What do you guys need? You need these things called what? Critical values. Is that right? So how do you get your critical values? What do you do now? You're going to use the what? 5% what? Level of significance. So what is alpha here? They're saying alpha is what? 5%. Is that right? Isn't that what they told us? Because that's your alpha? Easy peasy lemon squeezy? This is like everything we've been doing. So if alpha is 5% and there's two tails, how much is in each tail? Outstanding. 2.5% is in each. Is that right? And isn't that 0.25? Is that right? So, ladies and gentlemen, we got what goes in here, 2.5%. And we got another 2.5%. There you go. Easy peasy lemon squeezy. All right. Alpha's 2.5% now. Now, ladies and gentlemen, how do you get these critical values now? Remember, don't blink. You're going to have your test. When's your test for? Monday. Don't blink. Test 4. Okay. You blinked. How do you guys get your critical values? I know sometimes people hate when you remind them this stuff, but you got to remind them. Why do you got to remind them? Anybody know why you have to remind people? Why do I have to do that? Schedule. Test 4 is what? The 22nd. And then what happens the following week? Final exam. Oh, no. What if you're still asleep? Like, Mr. Judge, I'm still asleep. Oh, it's okay. Just wake up next semester. Got to wake up sometime. Do you guys know what I mean? You can't be asleep. This is college. All right, here we go. Why do I bring this up? How do I get critical values? Inverse norm. Good. That's why I'm bringing it up. Don't be asleep. So if I go to the TI again, should we use the old calculator or you guys want to use a new one? Huh? Old or new? All right. So second distribution, inverse norm. I don't know. We've been doing this all last week. It's still on 2.5%. Aren't we happy? Mu is 0. Sigma is 1. Good. Is 2.5% in the left tail? Is it there in the left? Yeah. So even if you use the old calculator, it's going to give the answer. So ladies and gentlemen, we're working on our preparation to be able to do the work. That's why you bring your calculators and we try this out, okay? All right, good. Now go down to what? Paste. And what do you get? Negative what? Negative 1.96, okay? Now you might say, is that my critical value? Yes. What's the other one, though? Positive 1.96. There's 2. So this is what we've been doing. We did this last week. It was a different parameter, though. This week we're starting with the what? With the mean, ladies and gentlemen. Anybody have any questions on your decision rule here? This is everything we did last week. Is that right? All right. What happens next in the process? Do you guys know? What happens next? You got to take a what? You take a what? A sample. What does it say? A sample of what? 200. What does that mean? Isn't that the sample size? And what are they saying? It has a mean of 4.6 kilometers and a standard deviation of 0.8 kilometers. So because we have a different parameter, this isn't successes anymore. This is getting a sample mean. Is that true? So the sample size is 200. The sample mean was 4.6. The sample standard deviation is what? 0.8. You say, how do I know all of this? Because they just what? They told you right in here, okay? There's your sample information. Okay, you guys okay with that? All right, so if you look at my notes, because I put these notes for you, I'm showing you everything you need to do in my notes. You say, Mr. Judge, is that in your notes? Yes. Oh, man. However, what do you guys have today that's new? If you're going to have a hypothesis test about a mean, yeah, hypothesis, put this as what? Hypothesis test about mu. Large what? Sample. Okay? This is a new day. This isn't last week. What do you guys have to do? You're going to use the z-test today. But remember something like we did from last week. We need, and I got out my green here. You see mu naught? What do you think mu naught is? What do you guys think mu naught is? Okay. What was P naught? P naught was the mean in the null hypothesis. You know what mu naught is? Right here. This is mu naught. It's going to be what? 5. So now, ladies and gentlemen, let's see what we do in the TI now. This is z-test now. We got to go to stat test, z-test. So this is a new day. You say, Mr. Judge, can I go back to last week? No. The bus is moving on, ladies and gentlemen. Stat test. Where do I go to now? Z-test, it's the first one. What's mu naught again? 5. Outstanding. And you go, oh my God, what's the standard deviation? Well, again, we got to do what? That's just, it's the same thing. It assumes that it's actually known, but whatever. So what does the sample information tell us again? Do you guys remember? 0.8. What's the sample mean? What was the sample size? 200. Was this a two-tailed test? Doesn't that mean two tails not equal? Mu not equal? Okay, then hit what now? Calculate. Okay, so some of you guys are going to have to go back up here. I apologize because we weren't looking at it. We got to go to stat, test, z-test. So mu naught was 5. The standard deviation, that's the same thing, 0.8, because sigma, ladies and gentlemen, that's really the population standard deviation. That's unrealistic. You're not going to be able to know what that is. So that's why we're using the sample information of 0.8. You go down to 4.6 for the sample mean. That was all in the sample. And then the sample size was 200. This is not equal. It's your two-tailed test. Is that right? Now you hit what? Calculate. And what do you guys see here? What is this? Yeah, your test statistic, ladies and gentlemen, is going to be what? The second what? Number. We're going to go to the nearest tenths. It's the z value here, okay? So my test statistic is negative 7.0 what? 7. So here's my what? Here's my test statistic. Where does that belong in your decision rule? Where is it? Isn't it to the left? Because remember how this works. We got to go over that. Any value between negative 1.96 and positive 1.96, any test statistic value, you do not reject the null. But because this is really past your critical value, it's like somewhere over here really, right? The test statistic, right? That negative 7.07. Okay, I'm going to get rid of this and say, isn't that test statistic out here negative 7.07? Yes. What region is it in? You're rejecting the what? No. Remember what we said, rejecting the null. We got to go to the null. And what do we say to the null? The null is what? Rejected. What is accepted if the null is rejected? The alternate. Is that true? Okay, you guys understand that? We rejected the null. And so that's why you cross out the null. Excuse me. But rejecting the null is really doing what? Accepting the alternate. What does that mean about your claim? Sample what? Does not support the claim. So the sample, ladies and gentlemen, does not support the what? Claim. There's your formal conclusion. Because we crossed out the what? The claim. So the sample information is suggesting that the mean is not 5. Okay, you guys with me on that? So that's what this is suggesting. The mean is not 5. And that's it, ladies and gentlemen. There's your first hypothesis test. But remember, in the TI, what's the function, what's the key that you guys use now? You use what? Z-test. Now, remember, I'm going to go over to the browser because I'm going to remind you guys. You go, don't remind me that the semester is ending. I'm going to go back to sleep. Don't be asleep, ladies and gentlemen. You say, do I get to use my statistics summary sheet on this test? What do you guys think? That's why I made it. So I just want to let you guys know as soon as this Wi-Fi can download it. There we go. Let's go all the way down. I still have to do a little bit of updating on this, but nevertheless. If you said, oh, we get to use a summary sheet. Yeah, we get to use that. Notice this. Estimating a mean. No, not this is estimating a mean. We are in what? Hypothesis testing about a mean large sample. So I remind you guys, hey, this is how you get critical values. And then you put stat test, z-test. Is that true? What do you guys think? So what do you guys really have to remember how to do? The process that we're doing. How do you get to learn how to do that? You got to do these questions over and over again, really. You got to practice. This is what we're doing. So we practiced all last week. We're practicing this week. And hopefully, you got your homework and all that, and hopefully you're good to go, right? Not too bad. Anyway. All right, ladies and gentlemen, let's do some more what? Practice. Practice what? Practice. And then it's on your notes as well, right? So I made some nice notes for you guys. Okay? What do you guys think? You guys have those notes? Should I publish this as a book? And become a billionaire? Move to Coronado Island? Go to Maui for, oh my God. You guys know I was at the Dodger game last week, Friday. My cousin had some tickets and we went together and I entered that 50-50 raffle. I was hoping I was going to win because if I won that 50-50, I'd be going to Maui. Oh my God. Anyway. No, I never win any raffles, no lottery. I don't win. Isn't that sad? Some people win, not me. I just work. If I publish a book with all these things, I get no money. It probably cost me money to publish it. All right, let's look at this one. What does it say? Got to stop our complaining. Got to get to work. The mean what? The mean IQ scores of college professors is what? Oh, what are they saying? No more than what score? 125 as what? Claimed by the faculty association. Oh my God, what parameter is a mean? U. And then no more than. What are they saying? What is no more than? Less than or equal to what? 125. No more than, less than or equal to 125? Isn't that the claim? Okay, you guys good with this? Because we've already done these kind of things now last week. So where do I put this, ladies and gentlemen? Is this a null or is this an alternate? Put it in the null position. Good, because it has a condition of equality. Now, what's the logical opposite of the statement? And the greater than, is that the logical opposite? Okay, now this is what we were looking at last week. Let's see if you guys remember. The alternate hypothesis inequality there always tells me what? What I need. Is this a left tail test, right tail test, or a two tail test? How do you know that this is a right tail test? What would you tell the person next to you? How do you know it's a right tail? The arrow's pointing to the what? To the right. All I got to do is know my right and my left? Yes, this is a right tail test. Okay. So, good job. Bless you, bless you, bless you, bless you. We got to label our regions. What do we label the non-shaded region? This is what? Do not what? Reject the null. What do you guys do over here? What is this? You're going to reject the null. What's your level of significance? Use the what? Alpha is what? Alpha is 1%. Is that right? And is it 1% 0.01 as a decimal? So what do you do with that 1%? What do you do? Isn't that all that 1% is in your what? Tail. Is that right? So this is where that 1% is. 0.01. I'm going to have how many critical values for a right tail? 1. Okay. Now, ladies and gentlemen, here we go. How do I find the critical values? Second distribution. What key? Inverse what? Norm. Is that true? Now I got to put 0.01 for 1%. This is the Z distribution, but I'm going to have to scroll all the way to the right. Why? Why do I scroll down to the right? It's a right tail test. We're looking for a critical value. Okay, now what do? Hit what? Paste. And what do you get? What is this? 2.33. So, ladies and gentlemen, 2.33. Now, I already know what you're going to say. What are you guys going to say? I already know. Isn't this portion over here going to be what? You say, Mr. Judge, I have the old calculator, and I need to know area to the right. Why is that 99%? If you're using the old calculator, the default, right? I'm going to go to the old calculator. I'm going to switch it out because some people have that old calculator. When you go to distribution inverse norm now to get critical values, you have to put 99%, like it's the confidence level, right? You're going to have to put that there. You don't have the option to go in left, right. You got to use the default. You guys notice that for some of you guys? You got the default area to the left. So when you use the default, don't you get the same critical value, 2.33? Because remember, the default here, this is the default. There you go. 2.33. You're done with your decision rule. This is a right tail test. This is where we left off last time, looking at left tail, right tail. All of alpha's in the tail. That's the difference. All of alpha's in the tail. So now when you go out and you take your sample, okay, they're going to give you a sample size, sample standard deviation. They're going to give you a sample mean. So you go out, you take your sample. You go, okay, what does the sample say? Sample of 120 college professors reveal a mean IQ score of 116 with a standard deviation of 8.5. So you might say, what is that? Well, here's N. Here's a sample mean. Here's a sample standard deviation. Let's write it down. N is 120. Sample standard deviation, 8.5, and the sample mean was 116. So now when you compute your test statistic, okay, remember that's going to be a z-value again. But what function do you guys use? You use z what? Z-test. Okay? So go back, and here's what I'm saying to you guys. Even in my notes, I go through what you need to do. There's in my notes here. I even say, oh, yeah, use z-test. Oh, yes. Don't forget our what? When you use that z-test, don't forget the mu naught. What's mu naught? For z-test, mu naught is what? It's going to be the what? The null hypothesis mean. Right up in here. So I'm looking for the null hypothesis mean there. Yeah, that's the mu naught. Okay? 125. So that's going to go in your calculator. Now, if you want to actually, again, use the old one, let's try that out. Maybe you guys want to try the old one. Stat test. It's already on z-test. It's the first one, z-test. Where do you go down to? What's mu naught? 125. Standard deviation, 8.5. Okay. Now go back up here because you say, wait a minute, I'm supposed to be on stats. Yes, stats. Okay. Now the sample mean is what? N 116? Is this a right tail test? Yeah, so you better be on the right tail. Is that pointing to the right? Yes. Scroll down and hit what? Calculate. What's your test statistic value? Oh, you're right. Sorry. Stat test. The sample size is what? 120. Is that true? It's not 1,200. Okay, no wonder that was so big. Okay, now we're good. Negative what? 11 point what? 60. Good job. It's the second line. That is your test what? Statistic. Now, where's negative 11 at? Okay, remember this. Any test statistic smaller than, to the left of that 2.33, do not reject the null. So if you're way over here, negative 11.60, what does that mean? To be way over there. Do not reject the what? The null. Aren't you in the do not reject the null region? You're in the do not. What does do not reject mean? You're not rejecting the null. Not rejecting means you're doing what? You're accepting the null. So go back and accept the null. Guess what? Accepting the null means you're rejecting the other guy. You happen to be accepting what? The claim. And if you accept the claim, what's your conclusion again? Sample supports the claim. Say, the sample what? Supports the claim. So ladies and gentlemen, your sample is supporting the claim. They're saying, you know what they're saying is what? They're saying that the mean is no more than 125, mean IQ score. There it is, ladies and gentlemen. This is what you're doing. Easy peasy lemon squeezy. It's all there. All right. You guys don't know that, some of you guys are going to be majoring in nursing, and you go, okay, because this is what, this for some of your majors, right? You're going to say the mean pulse rate of adult males is at least 72 beats per minute. You guys, maybe you know, maybe you don't know, but, pulse rates differ from men to women for whatever reason. I don't even know the reason. You got to ask the nurses. That's what you guys study, not me. I'm not a nurse. But I can share with you guys this hypothesis testing format, okay? What does it say? It says the what? The mean pulse rate of adult males is what? At least 72 beats per minute. So, and this is as claimed by who? As claimed by the Nursing Association. Okay? So, let's write this down. We interpret this, right? Mu, what is at least? Greater than or equal to 72. That's beats per minute. And that is the claim by who? By nurses. The Nursing Association of America. Whatever. Okay, you guys okay with that? So what does that mean we do? When we set up our hypotheses, we got to know, is that a null or is that an alternate hypothesis? Where does that go? That goes on top. That's your null. Is that right? Then we say what? What is 10%? That's your level of significance. If you know, we forgot to put the logical opposite. I apologize. What's the opposite of that greater than or equal to? Strictly less than. I was jumping ahead of myself because I know what's coming next. What do? I always look at the alternate hypothesis, H1, and then what happens there? What do I do now with this? Do you guys know? I do what? What is this? Is that pointing to the right or pointing to the left? So that means I have a left what? Tail test. So draw a left tail. In the middle, what? Do not reject the null. And then this is the what? Reject the null. All of my alpha is in this tail. See, I need the critical value. Is that right? Okay, what is alpha again? 10%. So what does that mean? That means 10% is in the tail, right over here. Is that right? So how do I get the critical value? Let's see if you guys remember. What do? We go to what? Second distribution, inverse norm. Okay, there you go. And now I got to put, what's in the left? What's in that left tail? 10%. So I can put 0.10. That's all I got to know. Isn't that it? 10%. This is the default after all. Okay. So paste that in. And what is the critical value? Is that negative 1.28? Is that negative 1.28, ladies and gentlemen? I think so. So here's my critical value, ladies and gentlemen. And I'm on my way. This is called the decision rule. Is that right? There we go. Easy peasy lemon squeezy. Okay, now remember, this is hypothesis testing about a large sample. I got to take sample information. I mean, about a mean, sorry. And it's a large sample. So I'll get a sample. I'll get a sample mean, sample size, sample mean, sample standard deviation. What does it tell me here, right? What does it say? Sample of what? 65 college students reveal a mean pulse rate of, what's the mean? 75.5. There you go. What's the sample standard deviation? 6.6. So the sample size is 65. Sample mean, 75.5. Sample standard deviation, 6.6, ladies and gentlemen. There you go. What do I use? Z-test. Is that true? Okay. What's my mu naught? Because that's going to be there. It's the mean in the alternate hypothesis. This is my mu naught, ladies and gentlemen. Okay, so we're going to have to use this information now. All right, let's try this out. Here we go. You guys ready? We can use the old stat test, the old TI Z-test. Okay, what's mu naught again? I forgot already. 72. Okay. What was this is really population center deviation, but that's highly unrealistic. You could use a past sample, whatever. Sample mean, 75.5. What's the sample size again? 65. What kind of test is this? Is this a left tail, right tail, or two tail? You may say, I already forgot. Oh, it's a left tail. Okay. So make sure the inequality is pointing to the left. It's the middle one. Is that true? That's your left tail test. So what's your test statistic value? What is it now? Z is 4 point what? 28. Where does 4.28 belong in your decision rule? It's positive. Remember this? Any test statistic value that's bigger than the critical value of negative 1.28 Do not reject the null. So your test statistic is really somewhere like over here. That's that 4.28. It's to the right of 0 somewhere. Do not reject the null. What does that mean, to not reject your null? You're not rejecting. What does that mean? You're accepting the null. What happens to the alternate? Your alternate's gone. Do not reject the null. You accept the null. What does that mean about the claim, though? Sample. Why does the sample support the claim? Huh? Because you just did what to the claim? You are what? You're accepting that claim. The claim happens to be the null. That's all. So, ladies and gentlemen, the mean pulse rate is going to be at least 72, and I guess that's for males. I don't even know, like I said, how accurate that is, but okay. All I know is the irony is, doctors are not always right. It's kind of funny. When you go to the ultrasound, I remember for my daughter, one of my daughters, because I have girls, the daughter, the ultrasound, the doctor is checking the pulse rate of the baby, and it was really fast. The beats per minute were really, really fast. And the doctor goes, "Oh, I think you're going to have a boy." I say, "How do you know?" "The pulse rate is fast, boy." You know what happened? Daughter came out. Another doctor. Talked to another doctor. Later on, my daughter was born. And, you go to the doctor checkups for the baby, and the doctor's looking at the baby's eyes, and the doctor goes, "Oh, she's going to have blue eyes." I said, "How do you know?" You know what the doctor told me? 30 years of experience. You know what color her eyes are? Brown. It's always funny when I do these problems, I think of the pulse rate, and it's kind of funny to me. Anyway, this isn't certainty, this is probabilistic. So what you're looking at really is hypothesis test. Scientific method is not certain, it's probabilistic. And we're going to talk a little bit more of that detail tomorrow, because right now we're working on what's called the modern method, and tomorrow we're going to do what's called the p-value method, which is you might see that in your life and career somewhere. So I have to tell you guys what p-values are. But I'm bringing this up because this is all probabilistic. Anyway. And of course, in the notes, I left these things for you guys here to go over and take a look. It's all in the notes. Oh, here's some of my favorite questions. Lifespan. Who's the oldest person you know? It's kind of what we're talking about, a lifespan. You guys know me, how long people live. You can even have an iPhone lifespan. Anybody have the iPhone 2 still? Yeah, I know. I have an aunt. We make fun of her because she has an old iPhone. She always wants everybody's iPhone when you move on. She doesn't want to buy an iPhone. She wants yours. Just give me yours. So every time you see her, you kind of laugh. You think, "Oh, she has an iPhone too." Yeah. All right. So what does this say to you guys? The mean what? This is a mean. What parameter is a mean? Mu. The mean lifespan of California residents is what? 77.8 years as claimed by the state of California. Oh, whatever. So how do we write this down? What are they saying? Mu what? Equals what? Because of the word what? Is. There's your claim. Is that true? Okay, so when we set up the hypotheses, where does that go? Is that a null or is that an alternate? Is that a null? Where does it go? Right? If it has a condition of equality, it's a null, and that's the essence of equality, equals. What's the opposite of equal? Not equal. Good. You guys see what I'm saying? Anybody have any questions on this part? Because what is the word is? That's what equals. That's short for is equal to. And that's a claim. So, ladies and gentlemen, notice our format is exactly what we've been doing. Is that true? Different parameter, though. Mu. Okay. So now you might say, what's the deal now? Is this a null or is this an alternate hypothesis? I'm sorry, rephrase that. Is this a left tail test, right tail test, or a two tail test? What is it? How do you know it's two tails? Not equal is always two what? Tails. Not equal in the alternate hypothesis, you always put your eyeball there. Always, always, always. When it's not equal, two tails. Okay, so draw two tails, meaning you have a left tail and a right tail. You shade that, okay. But what do you call the blank region? You what? You do not what? Reject the null. What about the left and right regions? You do what? You reject the null. So the critical values, you have to use what? What does it say? Use the what? 1% level of significance. Level of significance is alpha. Alpha is 1%. Is that right? So what does that mean? If alpha is 1%, you got two tails. What does that mean? A half, 0.5% is in each tail, 0.5%. How do you write 0.5? 0.00 what? 5. So I just want to let you guys know there is two tails, but half of 1% is 0.5%. Okay? So what do I do with them using the older calculator, right? Second distribution, inverse norm gives us these critical values. What do I do? What's this going to be? Point what? 0.005, because that's in, this is the default. Remember the default is always area to the left, right in here, to left of the critical value. You're using the default. So we're going to paste that, ladies and gentlemen, and you get negative 2 point what? Just so you guys know, you can say negative 2.58. That's fine. But just by, you might say, is it negative 2.575 or 5? What do we do? Let's do the hundreds, 5.8. Okay. And you have two critical values. The other one is positive 2 point what? 58. So I just want to let you guys know, I give you guys this in the calculator, and is that right? Did we screw up on that one? It's weird. Let's go back. I'm going to switch my calculator out. Second distribution, inverse norm, 99%. I'm going to put in the center. Right? Alpha is 1%. Yeah, negative 2.58, positive 2.58. Okay. Okay, let's do the z-test now. Right? Because we got to take our sample. A sample of 50 California residents revealed a mean lifespan of 76.2 years with a standard deviation of 9.8 years. So we're going to read this and get sample information from this. We need the sample. Sample size is 50. Sample mean is 76.2. Sample standard deviation is 9.8, right? It's all there. What's the name of what we use in the TI? Z what? Z-test. Don't forget, in the z-test, we need mu naught. Is that right? This is the mu naught, 77.8. Okay, so we have all that information. Now, stat test. It's already on z-test. That's the first one. Okay, what was mu naught again? 77.8, is that right? Now this is again, your standard deviation is 9.8. Sample mean, 76.2. What's your sample size? 50. What kind of test is this? Do you guys remember? Two-tailed test? How do you know? The alternate hypothesis, two tails. Calculate. What's your test statistic value? Negative 1 point what? 15. Is that right? Negative 1.15? Let's see where this lives in our decision rule. Negative 1.15. Okay, do you guys remember how this works here? Do you guys remember? Do not reject the what? Null if the test statistic is between negative 2.58 and positive 2.58. So negative 1.15 would be somewhere over here. Is that right? That's that test statistic value you just got. So what neighborhood is this in? Do not what? Reject. What is not rejecting? It's accepting. Do not reject the null. You just happen to be accepting the null, which is accepting the what? The claim. So what's your formal conclusion? Sample supports the claim. Good, ladies and gentlemen. Nice. 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 Okay. Insomnia. Nice. All right, let's take a look at this question here. The mean number of units college students take in a remote learning environment is not 12. Okay. The mean number of units is not what? 12 units. So what do you do there? This is mu. Mu is not equal to what? 12. Remember, claim by campus researchers. This is the claim. So the null hypothesis and the alternate hypothesis, where do you put the mu at? Mu not equal to 12. Where does that go? It's an alternate. Good. Thank you. What does that mean then? What's the opposite? The opposite of not equal is equal. Is that right? So, ladies and gentlemen, this is setting up the hypothesis here. They're going to want us to use the 10% level of significance to test this claim here. But remember what we got to do now, right? Which hypothesis tells you the kind of test? Yeah, it is the what? The alternate hypothesis. Now, if that's not equal, what kind of test is this? It's a two-tailed test. Is that true? Haven't we seen that over and over again? Okay, two tails. Now, draw two tails, because this is a two-tailed test. And where does your alpha go? What is alpha again? Isn't alpha 10%? What does that mean if alpha is 10%? That means what? Each tail is 5%. Outstanding. What do we label the non-shaded region? That's the what? Do not reject the null. And what's this region? Reject your null. All right, ladies and gentlemen, okay. We need critical values here. So what gives us critical values again? Inverse norm. Second distribution, inverse norm. Number 3. Now, 5% is in the left tail, so I put 0.5%. Yes, this is still the Z distribution. 5% is in what tail? The left tail. Isn't that what we have here? All right. Do what? Hit enter. What's your critical value? Negative 1.645. Positive 1.645. You may say, Mr. Judge, why is it in the thousands? Well, it's by tradition. If we use the Z tables in the past by tradition, that's what it went out to the thousands because that was a special situation. So I just kept the negative 1.645, positive 1.645. This tells us how to get, the critical values. It's in the notes. Okay, now we have to compute the test statistic, but to do that, we got to take a sample. Is that right? So what does it say? It says a sample of what? 350 college students reveal a mean. That's a mean from a sample called a sample mean. That's a mean of 10.5 units with a standard deviation of 2.3. Sample of 350. Okay, you guys okay with that? Easy peasy lemon squeezy. In the TI, what do we use? Z-test. But don't forget, in green, what's the 12 known as? This is our what? Isn't that mu naught in the TI? It's the hypothesis value in the null hypothesis. That's mu equals 12. So that's what's needed in the z-test. Is that true? So now you go to what? Stat test z-test. Okay, we're on stats. Mu naught is 12. Is that true? Standard deviation is 2.3. What's the sample mean? 10.5. Sample size is 350. Is that right? And what kind of test is this? Is this a two-tail test? What do you guys think? Is it? I think so. Yeah, it's two tails. Okay. Hit calculate. What's your test statistic value, ladies and gentlemen? What's that number? It's negative 12.20. Is that true? Did you guys see it? Where does that live? On your decision rule, negative 12.20. Isn't that really way where? And that's really over here. Is that right? Isn't that bigger than your critical value? Well, yeah, I mean, it's, oops, sorry, negative. It's on the, oops. It's weird. Negative 12 is on the left over here. This is where your test statistic is. So it's going to be in what neighborhood? Yeah, it's really over here. This is in the reject the null neighborhood. So you reject the null, because that's where negative 12.20 would be. It's really off the iPad. Going to get rid of this. What does rejecting the null mean? You say, you know what, null? You're gone. You have been rejected. What are you accepting then? If you reject the null, what do you have to accept? Good. And that happens to be the what again? The claim. So what's your conclusion? Sample supports the claim. So I hope you guys enjoyed the process. I hope it's easier today. I hope it's getting easier, but it should be getting easier. Why? Because you're seeing the same kind of examples over and over again. It's just with a different TI command, because it's a different, technically it's a different parameter, so it's a different task. So remember, again, I give you guys these sheets here. Tomorrow, we're going to do what? Hypothesis testing for small samples. In that case, you're going to use the t-test. And your critical value is going to be inverse t. So I did put your homework where? Is your homework there? Yes, it is. You say, Mr. Judge, where is that? Statistics Lecture 14. Is that right? So notice again what I did with Statistics Lecture 14. Your homework is here. It's these questions. You should be able to do more and more of them. And again, if you get stuck, what can you do? You got your tutors here. You got your TI tutor. Easy peasy lemon squeezy. All right, ladies and gentlemen. Okay, so I'll see you guys when? Tomorrow. Take care and stay safe.